Lepidodendron was one of the giant plants that helped create the swampy forests of the Carboniferous period more than 300 million years ago. It could reach around 30 meters in height, but despite its tree-like appearance, it was actually a giant relative of modern club mosses. Its trunk was covered in diamond-shaped leaf scars, giving the bark a striking pattern. Instead of producing seeds like modern trees, Lepidodendron reproduced using spores. Its shallow root system and rapid growth allowed it to dominate enormous wetland forests. When these forests were buried and compressed over geological time, their organic remains contributed to many of the coal deposits formed during the Carboniferous. Sigillaria was another towering plant of the ancient Carboniferous coal forests, sometimes growing more than 20 meters tall. Its trunk was relatively narrow compared with its height and was covered with distinctive vertical rows of leaf scars. Like Lepidodendron, it belonged to the ancient Lycophyte group and reproduced with spores rather than seeds. Its leaves formed clusters near the top of the trunk, creating a crown that made the plant resemble a strange prehistoric palm. Sigillaria thrived in warm, wet environments where vast forests covered low-lying areas. When those forests eventually died and became buried under sediment, plants like Sigillaria contributed enormous amounts of organic material to the coal-forming ecosystems of that era. Calamites looked surprisingly similar to the horsetails growing beside wetlands today, but its ancient relatives could become enormous trees. Some species reached heights of roughly 20 meters and had tall, segmented trunks with branches arranged in regular patterns. They lived mainly during the Carboniferous and Permian periods, often growing along rivers and in swampy environments. Their hollow, jointed stems were supported by a woody outer layer, allowing these plants to reach heights impossible for modern horsetails. Calamites reproduced using spores and could spread through underground structures, helping them colonize disturbed wetland ground. Fossils of their ribbed stems are common in ancient rocks, giving scientists a detailed glimpse into the forests that existed hundreds of millions of years ago. Araucarioxylon is a fossil wood name associated with ancient conifer-like trees, particularly those preserved from the late Triassic. Unlike a living species, the name is used primarily for fossilized wood identified from its anatomical structure. These trees belong to forests dominated by early conifers and other seed plants, living in landscapes where some of the earliest dinosaurs were already appearing. Their woody trunks could become substantial, allowing them to form tall forest canopies. Fossilized Araucarioxylon wood has preserved microscopic details of ancient growth, helping scientists reconstruct past climates and ecosystems. It is a reminder that prehistoric forests were not simply smaller versions of modern forests. They contained entire communities of plants that have no direct living equivalent today. Cordaites were tall, woody seed plants that lived mainly during the Carboniferous and Permian periods more than 250 million years ago. Some species could grow into large trees, reaching several tens of meters in height. Their long, strap-like leaves formed dense crowns, giving them an appearance quite different from the giant Lycophytes growing beside them. Unlike Lepidodendron and Sigillaria, Cordaites produced seeds, making them part of the ancient seed plant groups that eventually became important in later forests. They lived in both wet lowlands and drier environments, showing that prehistoric forests were far more diverse than a simple swamp filled with one type of tree. Prototaxites is one of the strangest giants in the prehistoric fossil record, and scientists still debate exactly what it was. It lived during the Devonian period, roughly 420 to 370 million years ago, when Earth's land vegetation was dramatically different from today's forests. Some specimens reached several meters in height and had enormous trunk-like bodies. For a long time, scientists classified prototaxites as a plant, but chemical and microscopic evidence has increasingly supported the idea that it was a giant fungus or fungus-like organism rather than a true tree. Whatever its exact identity, its enormous size makes it one of the most bizarre structures ever to dominate Earth's early landscapes. Wattieza was an ancient tree-sized plant that lived during the Devonian period, roughly 390 million years ago. It is closely related to early tree ferns and is known from fossils that reveal a tall trunk topped by a crown of fronds. Some reconstructions suggest it could have reached around 8 meters in height, making it a giant for a world where forests were still relatively new. Unlike modern seed-producing trees, Wattieza reproduced through spores. Its existence shows how early forests were already beginning to develop vertical layers, with tall plants creating shade and changing the environment around them. Fossils of Wattieza provide important evidence about the early evolution of forests long before flowering plants appeared. Paradoxopteris is a fossil plant name associated with prehistoric tree-like vegetation, but unlike famous living trees, its exact biology is reconstructed mainly from fossil evidence. Plants placed in this group lived during ancient periods when Earth's forests were dominated by non-flowering seed plants, ferns, and other early vascular vegetation. Their branching structures and reproductive organs provide clues about how prehistoric plants occupied forest space. Because fossil plants are often preserved as separate leaves, stems, wood, or reproductive structures, identifying their complete form can be challenging. That uncertainty actually makes Paradoxopteris fascinating. Scientists must piece together fragments of ancient forests to understand what these long-extinct giants may have looked like. Psaronius was a giant tree fern that lived mainly during the Carboniferous and Permian periods, when enormous fern-rich forests covered parts of the planet. Some species could reach around 10 meters in height. What made Psaronius unusual was its massive trunk, which was built from a dense network of roots growing around the central stem. Those roots helped support the tall plant and gave its fossilized trunk a distinctive pattern. Unlike modern flowering trees, Psaronius reproduced through spores. Its fossils show that ancient tree ferns were not small woodland plants. They could become major components of prehistoric forests and rise high above the vegetation beneath them. Medullosa was a remarkable seed fern that lived during the Carboniferous and Permian periods. Although it looked somewhat like a tree fern, it was actually a seed-producing plant, making it very different from true ferns. Some members could grow several meters tall and carried large fronds that formed a broad crown. Their seeds allowed them to reproduce without relying on free water for fertilization, an important advantage for seed plants spreading across ancient landscapes. Fossil stems and seeds have helped scientists reconstruct these strange plants, which disappeared long before flowering plants became dominant. Medullosa represents one of the many unusual evolutionary experiments that once filled prehistoric forests. Glossopteris was a dominant seed plant group in parts of the ancient southern supercontinent Gondwana during the Permian period. Its tongue-shaped leaves are among the most recognizable fossils from these ancient landscapes. Glossopteris plants could grow as shrubs or trees, depending on the species and environment, and they produced seeds rather than spores. Their fossils have been discovered across South America, Africa, India, Australia, and Antarctica. This wide distribution became important evidence for the idea that these continents were once connected. The leaves did more than preserve a picture of an extinct plant. They helped scientists understand how Earth's continents were arranged hundreds of millions of years ago. Dadoxylon is primarily a fossil wood name used for ancient conifer-like woods rather than one clearly defined living tree species. Fossils assigned to this group occur in rocks from several periods and regions, preserving the internal structure of prehistoric tree trunks. Some belong to large woody plants that formed forests long before modern conifers dominated many landscapes. By examining growth rings and microscopic wood patterns, scientists can learn about the climates in which these trees lived. Dadoxylon therefore gives us something fossils rarely provide so clearly, a close look inside the trunks of extinct trees. Even without seeing the original forest, the preserved wood can reveal how these ancient giants grew and responded to their environment.